MEQSilhouette and EHT imaging, two softwares used in the event horizon imaging process. I'm going to talk exactly about how these softwares work and their key roles in the Event Horizon Telescope initiative. I'm going to start by giving a brief background on the Event Horizon Telescope. This virtual telescope consists of 9 individual telescopes that work collectively to create a virtual telescope with the resolution of a telescope the size of the Earth. 2 of these telescopes are located in the United States. Seen on the left here is the James Clerk Maxwell Telescope located in Hawaii, and on the right is the Arizona Radio Observatory located in Arizona. The way the Event Horizon Telescope works is these 9 telescopes point their dishes at the same subject from different spots on the Earth at different times. This data is later synced precisely and combined at MIT Haystack Observatory to create one final image. That recorded data is then sent to the MIT Haystack Observatory physically because it cannot be sent over the internet. The data sets are just way too large. At the MIT Haystack Observatory is where these softwares come into play. The data is then corrected and inferred by MEQSilhouette and EHT imaging. The reason that the data needs to be corrected is because it's not necessarily accurate as it's being recorded. Things like gravity, wind, instrumental noise, and other things can affect the recordings. The way MEQSilhouette software works is we record these things that can cause errors in the recordings while the telescope is taking images, and we input that into the software and it tells us how we can correct the data. You can think of MEQSilhouette software as glasses for our telescopes. It basically sharpens up the image for us and brings it truer to life. The way that EHT imaging software works is it fills in the missing gaps of our image. If we go back to the diagram before, we'll notice that the entire globe is not covered in telescopes. This is something that just isn't physically possible. So we have to rely on software to fill in those missing gaps. The way that EHT imaging does this is by inputting models of black holes that we know are possible based off of laws of physics, and also by inputting our corrected data from the MEQSilhouette software. With the combination of these two, we can infer the rest of the data using EHT imaging software and fill in those missing gaps, completing our image. These two softwares running in tandem require a lot of horsepower to power them. Not just because there's terabytes of information to be processed, but because these two softwares require weeks to run. It's a very, very time-intensive and resource-intensive software. So the engineers at MIT Haystack Observatory developed a supercomputer to get the job done. This supercomputer consists of 800 CPU cores that take just shy of 3 weeks to do one run on the EHT imaging software and MEQSilhouette software to construct an image. Generating an image of a black hole with the Event Horizon Telescope is something that cannot be done without the use of software such as MEQSilhouette and EHT imaging. These softwares act to correct the data that we already have and infer the rest of the data that we know we can't record. Thanks to these new and innovative softwares, we can look forward to groundbreaking discoveries like the first image of a black hole as early as 2020.